Hello everyone, welcome to another Kinetic tutoring video. Today we're taking a look at another AP Physics C mechanics question. So let's just get straight into it. A block of mass M is pulled along a rough horizontal surface by a constant applied force of magnitude F1 that acts at an angle theta to the horizontal as indicated above. The acceleration of the block is A1. Express all algebraic answers in terms of m, f1, theta, a1, and fundamental constants. On the figure below, draw and label a free body diagram showing all the forces on the block. So we know we have gravity. I'm going to have friction. Gravity's going down, friction's going to be perpendicular to the plane, and we have our force F1 that way. Derive an expression for the normal force. Oh, we also have our normal force going upwards. Derive an expression for the normal force. So since the block is moving horizontally, it's going to be not moving in the vertical direction up or down. So our net force is going to be 0. We have mg going downwards. We'll choose that as a positive direction. And upwards we have F1 sine theta, the vertical component, minus F1 sine theta minus normal force. And that's why our normal force is going to be mg minus F1 sine theta. C asks us to find an expression for the coefficient of kinetic friction mu. Alright, so we know that in the horizontal direction, the acceleration is a1, so we'll have ma1 is equal to F1 cosine theta, the horizontal component of the force, F1 cosine theta minus friction, and we know that our friction is just mu times normal force, which is just mu times mu normal force. And if we're looking for mu, we're going to move this ma over and this to the other side, so we'll get mu n is equal to F1 cosine theta minus ma1. So therefore our mu is going to be F1 cosine theta minus ma1 over n, which we have the equation for here. So we're going to write that mg minus F1 sine theta. So there you go. There's your final answer for mu. Let's move on to part D. On the axis below, sketch graphs of the speed v and displacement x of the blocks as a function of time t if the block started from rest at x equals 0 at t and t equals 0. So since there's a constant acceleration, the velocity is going to start here, and since the acceleration is constant, it's going to look like this. And therefore, knowing what the common graph looks like, the position one is going to look like this, because we know when we take a derivative, if our acceleration is a constant, our velocity is going to be our constant times time, and our position is going to be 1/2 constant time squared, assuming that it starts at 0 displacement and at rest. Alright, if the applied force is large enough, the block will lose contact with the surface. Derive an expression for the magnitude of the greatest acceleration the block can have. So we know that the block will lose contact with the surface when the horizontal or the vertical component of this force is equal or greater than gravity. So it needs to be greater than gravity, so the largest it can be without the block lifting is going to be equal to gravity. So we'll get, this is the sine theta, so we get a1 sine theta is equal to mg, and therefore the largest that A max is going to be able to be is mg over sine theta. So there you go, there you have it. That's how you would solve this problem. Let me know if you have any comments, questions, or concerns, anything I can help you out with. And yeah, that's all I have for you guys today. Make sure to have a great rest of your day, and I'll catch you guys next time.